Zakharov, and today we'll briefly speak about the LIS, Laboratory Information Systems. What is it for, how to manage and implement this class of solutions, and what value are we to expect from this if we go into this river. First of all, I'll briefly introduce myself. I am the Chief of Project Management Office of a small IT company, Across Engineering, that Russian company. And our key area of expertise is to develop and implement LIS solutions for the customers from all over Russia. We are quite good at our job. We have some awards, some certifications. So my today's lecture is more about the specific of how to deal with this class of IT solution and not about the functionality of the LIS itself, because 1 hour is a pretty brief format, so we'll be unable to look at this. So first things first, as you know pretty well, I think, the development of healthcare technologies has plenty of reasons. Medical equipment is very complicated nowadays, and the healthcare process is more and more complicated with each next iteration. It generates the massive amount of data. I have seen very curious graphs that indicate the growth of data volume in healthcare is like an exponential curve on the graph. Because of the Internet of Things, of course, because of AI, because of big data that comes to our life. Yes, of course, it was originally invented for the retail industry, but and it came much later to the healthcare segment, because the healthcare segment, we must understand, is much more conservative usually in applying new technologies, and it's very reasonable, we must say. So the key aspects we are to consider is licensing and budgeting, because IT and modern IT is quite expensive, so you have to understand as further chiefs of medical divisions that you, in the modern reality, you are always a little bit of IT director. It's a normal thing, there's nothing to be afraid of, but it is what it is. It is also the expertise you have to consider and have to implement in your skill set. There is, of course, functionality and technical infrastructure. Very important thing. You have heard a little bit about hospital information systems, yes? And the common understanding that hospital information system can involve in itself all the functionality for radiology, for electronic recipes, for emergency care units, for patient in-house logistics, for sanitizing the instruments, and of course the laboratory. And yes and no, because for certain amount of solutions it's reasonable. But if we speak about bigger laboratories, about more serious laboratories, it's usually not enough. So what about the world trends and the labs? All clinical healthcare process strongly depends on the data from diagnostics. And first of all, it's the data from clinical labs. With the new machinery they use, with the new test systems that come each and every year, and every vendor has its own new portfolios. With all the modern approach, it rapidly incorporates a lot of modern technologies. For instance, we speak about clinical decision support, we speak about machine learning, we speak about the same big data. About the clinical decision support and AI, there are a lot of different opinions in the world nowadays. For example, in North America, we have taken a lot of conversation with the guys from here. They say that only incremental approach works. So they take a very, very, very particular problem. They decompose it to very, very certain processes. They put it into machine language, automated solution for only one very particular problem, and they increment it into the hospital information system. And this, in their opinion, is the only way for healthcare IT that actually works. And one of the most common tendencies, they strictly avoid the word clinical in decision support. Consulting system, healthcare, decision help, something like that, but not clinical, because it can bring them to very strict certification they possibly will not be able to achieve. So, what is more correct when we speak about clinical labs? We don't take for today the clinical process itself, but we should look at this as the production. So it's very complicated, very modern factory, which has a very, very certain product. This product is diagnostics information. It's a very expensive, very valuable and product which has very, very high demand. And since we speak about the production and logistics, it is more than reasonable to incorporate the logistical terminology, such as the percent of perfect order fulfilled. What I mean? In supply chain, there is a key aspect. The percent of the order that have been fulfilled on time, in the right quality, to the right place, and with right complex. The closer it is to 100%, the better works our supply chain or production. So completely the same thing is more than appropriate for the clinical lab. And of course, when we speak about very large factory with very, very expensive equipment, I think you understand better than I do that the modern analyzers can cost from 2,000 euros for something like glucose measurement to €500,000 for robotized facility for microbiology or histology or hematology. And it's not the limit. So it's a very, very expensive approach to build and to feed and to maintain the good clinical lab. But from the business terms, what can give you a well-established lab, well-managed lab in money? According to the statistics we have, for several Russian objects, it can vary from, for example, 20% return on equity to, let's say, 45% of return on equity. And this is pretty much because 20% return on equity is the level comparable with the oil and gas industry, for instance. And 45% is the level of the A-class American high-tech corporations. So it can be very, very profitable, but the completely opposite is also sure, because bad management for this production can destroy your bank account in no time, usually. So this is the understanding we are to consider always when we speak about the lab. Two approaches to choose this implementation scenario for LIS system. First of all, you usually have the hospital information systems provider that says, oh yes, okay, I have a laboratory information system module in my portfolio and I just can give it to you with a low price. And if you have a small lab and you don't have anything much to expect from it, you just have reason to get this covered, so it can be a reasonable scenario. But it's usually poor functionality. It's very, very interoperable because they integrate with themselves, and it's an easy game, in my opinion. But no miracles will happen here. And the second is you have a serious lab. For instance, you have quite a large hospital or ambulatory diagnostic center, and you say, no, I want this tailor-made. I want this exactly be suitable for my business process, the way I see it. I want to grow with it. And this is a quite different class of solutions. It's not very reasonable to classify it as a production module because it's more than this. I'll tell about this a little bit later. But it's just like mini ERP system. Enterprise resource planning for those who is not familiar. So it can be very, very autonomous. And this is, when you speak about the branch of specialized solutions, can bring you some additional benefits, but it's more complicated in installation, it's usually more expensive and takes much more attention from the PM responsible for it. So, when you hear about laboratory information system, first of all, what's the first opinion you have? Connect the analyzer. Oh yes, okay, I have a dozen or 2 dozen instruments and I want them connected. Give me the LIS. Because that's what's it for. Yes and no, because if we look at the history of LIS solutions from 80s to nowadays, it was originally the instrument of accounting. You had to calculate everything the lab does during the workday. You have to calculate what has come to you as an order, what did you give away as a result, what has been happening in between these stages. This idea was developed in early 90s when the database systems have been involved in this process. What is it for? For example, you need to perform and compound the quarter report. You have been working for 90 days or so, you have a big lab, you want to give a report to the executives of the hospital. You, in the first generation of LIS, you make combine and it will combine, for example, 1 day. And if you have a database system, it will combine in 5 minutes or 4 minutes or 1 minute. So it was a very, very big step forward. And only in late 90s, there were automatic analyzers, Olympus, Hitachi, etc., that had the interface to connect it to LIS systems. And that was the third generation, so 2 generations passed. Then it was 2000s and to nowadays, and on the top of the game today, and not only in Russia and the world itself, is the question of interoperability, of course. The question of interoperability is the headache of every IT division of hospitals, of healthcare system, and not only in healthcare, I must say. And it can be sometimes very, very tricky, because pretty often you don't have any chance to get an influence for the external systems, because they are what they are. And you have to accept these rules of the game and to incorporate it in your plans and your IT infrastructure and into your IT ecosystem, I must say. So the data exchange there, it's not full list, but you have manual entry of orders to tests. You have hospital information systems and order from this. You have data exchange servers that can be regional or federal level. You have QR coded blanks when you read the QR and take automatic order encrypted in it. You have machine forms, it's just like scanner but for machine reading blanks, or other external system, and a lot of data to output. So it's also an aspect you have to consider very, very carefully, because they all have different protocols, they have different teams of development, they have different terms and plans, and it's pretty tricky, but it is the reality of modern healthcare IT. So, what can we say about the value of the data that usually has a large clinical lab? Who is interested in it? Patients, very interested. Clinical specialists, very, very interested because it's a healthcare process and it's what they get paid for. Of course, with the modern concept of patient as CEO, patient as chief executive officer, that has the ultimate decision right in all questions related with his personal healthcare. In this concept, a lot of medical innovations nowadays is being developed, both in North America, both in Western Europe, both in all over the world. So, of course, the patient is starting to be very demanding to the quality of his data, of his lab data, after all. But it's not the only thing where we can use this data. It is very, very useful, as we all understand, in epidemiology. For example, yes, COVID-19 has improved these questions drastically. It can be just like digital gold for the pharmaceutical companies, because what? Because they always have clinical trials. And if you have some new pharmaceutical development for very, very rare or even orphan disease, you have to get the right control group to perform the clinical trial. And then for the rare disease, it's a huge problem. So you need a lot of diagnostic data for patients, for example, with chronic diseases, relevant data, with relying on which you can choose your control group. And of course, the government. Because the government, for example, they say, I would like to see all male persons over 45, from 45 to, let's say, 60 years old, with high meanings of cholesterol, troponin, something like that. Or they want to say all pregnant young women under 24 years old with low iron and low some hematological indicators. Because this is the question of statistics. This is the question where exactly the healthcare system, the particular health system, has to undertake more efforts. Because it's not a secret for any of us that not a single healthcare system on the planet, not even in North America, is able to afford to develop all the directions of medicine at once. It's just impossible. Not from budget, neither from budget nor from resources, never. And they have to prioritize the tasks. So, a few words about the inner process and the workload of data inside the laboratory. It's a very, very brief scheme. You have some analyzers that each and every of which can generate its own data packages. You have some production modules. It may be one module, it may be much more modules, up to 5 in my practice. And you have an LIS as an aggregator, and you have the external systems. Among our customers in Russia, there is one Moscow laboratory that has the day volume, how was it? Something like 26,000 orders per each day, which they work with. So it's like 150 instruments. It's like 4 or 5 middleware solutions and the LIS that aggregates all this amount of data. And it's thousands, maybe millions transactions. So the infrastructure for this, the IT infrastructure for this should be also the same quality. And this you should understand very clearly. The economy on the infrastructure for the implementation of LIS can be very little sometimes. But what is it for? We have undertaken a lot of efforts. We have taken this headache with LIS project. But what is the benefit we're able to take? First of all, of course, it will be the increasement of laboratory productivity. It can vary from, in our practice, from 15 to 45 or 50%, almost in a single night. It is the full-scale monitoring of everything that happens in the laboratory. So, what is valuable? You are able to limit the responsibility of the lab, because you can precisely say where exactly and when exactly did come this particular sample with this order. And from this place, you can say exactly to the minute precision where it was, what result has been taken, who was responsible, because everything is being logged in the system for this sample, and when exactly have been the results uploaded. And because of the barcoding system and because of logistical system, sorting drives, archives, the sample flow in the laboratory becomes much more manageable, because all the unnecessary solutions will be eliminated during the good LIS implementation. I must say that this process usually is very, very demanding to the quality of business process, because if the laboratory was badly organized, you won't get the effect. Because badly organized production with a good IT implementation is still better than badly organized production, but with IT. Of course, that's not what we originally wanted to do. And quality and reliability, because the funny thing, but the clinical specialists and the patients, even more than the clinical specialists, are very demanding to the quality of the results. They like to rely on it, and they get used to rely on it, and they don't want to lose this habit. So, in brief words, we'll speak about this at the moment. How to get the maximum of the idea of LIS implementation. First of all, very, very precisely determine the needs of your particular lab production. You have to get the first approach to the budget you're able to spend to this activity. Choose the right solution and the contractor, and we'll speak about this a little bit later. Yes, I forgot to say. When you speak about the return on investment, and the IT implementation is also return on investment, of course, because it's an investment project. There are two main approaches of how to estimate the efficiency of implementation of every IT solution. I don't speak about only LIS, I speak about every IT solution. First of all, it's the empirical approach. You assemble the statistics, or you take the statistics as already assembled, of how exactly your colleagues with comparable productions have benefited because of the implementation of such class of solutions. And in an empirical way, more or less precisely, you can adjust it to your expectations. Or the second scenario, much more rare, it's when you have a very, very detailed broken down the model of organization, where every part of business process is determined, estimated, broken through, and you can calculate the cost of every branch of the business process. It's a luxury that almost no one can afford usually, because if you speak about the consulting contracts for such work, it can cost you, guys from Ernst & Young can take from 100,000 euro for this job and up to the stars. Something like 400,000 euro can be not much in their price lists. There is, and we'll speak about this later a lot, there is a homework that no one except you can be able to perform. And of the quality of this homework strongly depends what happens next? You have to get vision. Of course you will adjust it, of course you will correct it, but you have to get an initial clear vision. What you are to get in the end. And about the risks. Well, time for scary movies. When you speak about the expensive things, you understand quite well that the expensive things can be broken. For instance, if the contractor connects your very, very expensive PCR analyzer or something like TrackLine and burns down, for example, the COM port for it. The COM port for one of the top world vendors, will not name it, can cost you something like 4,000 euros each. And what's more scary, it can be just out of stock. So the next supply will be coming from German in 4 weeks, for example. And in 4 weeks, your hematology analyzer will be completely useless. Even more funny that if you have the hematology center, I have seen such cases and it was unpretty. Or you have some unplanned obstacles, and you will have some unplanned obstacles. Just because of this, you have to get at least very, very general risk plan. What aspects of work of your hospital can affect the LIS implementation? And ask yourself these questions and write down the answers and what you will avoid, how you will act. Okay, if things go the right way, okay, let's just go and put it into the shredder. If it doesn't, what if it doesn't? And it's also just an aspect of project management that you have to consider. It's my favorite cup of tea, project management, because I am a career project manager. Of course, I look at the things from the business process view and from management view, first of all. Forming the project group. It's a very, very interesting stage because you have to choose the right person to be your project manager. It has to have a lot of authority, it has to have a budget, it has to have obligations, of course, and he is to be able to perform the work you gave to him. It seems obvious, but it's not as obvious as it sounds, because I have seen a lot of situations when the hospital assigns the project manager and says, well, this guy is responsible for all healthcare IT model upgrade the hospital has. But they forget usually to give him the budget, the authority, the team. So yes, there is the project manager, but there's nothing much he can decide usually. And another very important aspect, it should be a person with a vision, because there was a curious research of Standish Group about the rate of success of IT projects in every industry. And they have a very unpleasant graph that indicates the following. The bigger the volume of IT project, the less probable that it will be successful. And it's right direct correlation. And in my opinion, as a professional in project management, that's because from a certain point, there is a strong lack of person who single-handedly has the complete vision of what actually happens. Where are we going and what the hell, how can we manage with this? So, and most of all, don't forget that even if you choose a good contractor, yes, professional, top-rated, expensive, very well, there is still a job that a hospital, that your specialists are to perform in order to get things right. So, when you prepare the briefing about the laboratory, you have to compounded in different aspects. Detailed laboratory info. What test lists laboratory has, what services it provides, what equipment it has. Is there anyone who has service contracts? It's very important for this equipment. Which year has been supplied? There is a lot of aspects because the software, the management software, for example, can be different versions for the instrument, and the different version of software can have a lot of different aspects. For example, you'll have to get separate driver for this. You'll have to get an upgrade for this operational software. Because in order to avoid the situation where the instrument cannot be implemented when you need it and you'll be out of time to make anything with it. Laboratory specialty, of course, because you know your specifics much better than your contractors usually do. For example, you have an emergency healthcare. This is one aspect. You have HIV center for dangerous infectious diseases. It's the different center. You have the oncology. It's the third aspect. You have pathomorphology. It's a different aspect. And this specific doesn't matter for the implementation. And what are your customers usually? A little bit about who is the consumer of your efforts. It is a very important part to form and compound your vision. So, the cost of LIS and the cost of any IT solution, I must say. First of all, yes, of course, a license fee. There is a curious aspect. Some providers give you the license just without the terms limitations. So they just give it to you, and until the solution exists, you can work with it. The personnel efforts, both yours and your contractors. As you know pretty well, the healthcare specialists as well as the IT specialists are usually very well paid. And each day and usually each hour their work costs a lot. Rooms preparation, of course, because for example, you don't have a local area network, you don't have some server room, you don't have something else. You have to make it. Additional hardware, usually. If the laboratory didn't work with IT solutions, usually there is plenty of work to get your hands dirty. Additional software, not including the LIS, operation systems, some drivers, some modules, some upgrades, it also should be considered and fulfilled. Materials. Yes, the funny thing, but when you test the instrument connection, you have to get some spare reagents just to run the test samples. Doesn't matter, to make sure that everything works right. Then LIS adaptation, of course, because it's programming. Usually, if you have the business process LIS have to answer for, you have to include these works. Installation process, of course, and what's special is overtime. There is a joke in our industry that laboratory specialists divided into two big categories. The ones who saw the first day of launch LIS system and the ones who didn't. And when you see the first group and you say, oh, the first day of LIS system, their eyes become very, very wide, like two balls. And that's for the reason, of course. And the cost of ownership. Course, service fees, additional costs. Every contractor usually has his own policy. For example, not everyone gives away his license forever. Someone can only give it for the rent, and you have annual payment. You have to be ready for that. And the risk estimation, because a lot of risks you have a monetary dimension, and you have at least to be able to have ideas where are you have to get money if things go wrong, and you extremely fast will need this and that, and adaptation lags, of course. limitations of choice are quite obvious from what we're speaking about. The price. Your desires are to be compatible with your budget. That's always is. Project terms and limitations. You can have your own plans, you can have your own requirements or something like that. You have to consider scalability requirements. For example, you establish a new commercial clinical lab. Okay, you start from 500 samples per day, but your plan is in 3 years to have 5,000 samples per day. And everything you initially start should be scalable to this. Otherwise, you can get the necessity of reinstalling everything you so heroically did. And a lot of other, security. That's very, very important. Security and regulatory requirements. You have different countries, you have different laws and regulations for healthcare and IT products. Russia, for example, has a specialty that it is quite demanding for information security, but I assure you that North America is not a single drop less demanding in these questions. And of course, it's always a very painful question when a lot of patient data just leaks away to the different source where it shouldn't actually be, because it can be very, very serious, and you also should consider it. With security officers that work in your hospital, you have to make it. Then functional requirement, of course. So I think it's the contractor's choice, of course. It's quite common for any IT contractor you'll be able to see in your practice. Do not ever believe in promises of contractor. You have to get your own small research. Look at the places they indicate as their customers. Communicate with their customers and carefully ask about how it was, how the guys like, what mistakes were taken, and what lessons they have learned. You have to get this picture in 3 dimensions for yourself. Then, and of course, you have to pack up and go to the field. You are to go on foot at least one installation this particular contractor has performed, because only this will give you a vision of what potentially you may have. And of course, it should be precise and correct, because one thing is to install LIS system to the lab that actually doesn't work and will start working with the new LIS system. It's much more easy game, I assure you, than changing the LIS system for the large lab that already has a lot of volume, that already has some urgent research and works 24/7. It's a completely different game. Of course, we can play both, for example, but I assure you it's much more difficult. And specific LIS solutions, of course, because LIS is also not a monolith. It has different modules, it has different branches, QC, reagents accounting, cryptography, etc., etc. And I think that we just can see a few words about it. Quality control. Usually it's just to work with standard deviations and variations and specific data that instruments can usually automatically exchange with LIS. It can process this information with individual setting of like Westgard rules, some of them which you currently use. It's Levy-Jennings graph and graphical approach. It's also it can store the error logs from instruments, Levy-Jennings and most important, the QC module the contractor gives you should fully be compatible with your regulatory requirements. What actually the higher instance demands from you, your QC module with the installation should be able to provide. And of course they upload to the external services like BioRat, Unity or FSWalk and something like that. Reagents and accounting functional, of course, and we don't usually speak about just the primitive warehouse, where the box of reagents has come to us and the box of reagents is out for us. What happened in between, we have no idea, and we don't want to have. It's the first stage you can use, or you can go down to something like production accounting. For example, you can forecast the spending of reagents for the certain period of time with using the statistics you have already assembled during the last periods of time. It's very simple because the more statistics you have, the more statistical row you have, the more precise will be your forecast, of course. You can have automatic alerts about, for example, guys, you have only 10 days of bilirubin on the architect. You have to do something with it, guys. Or, for example, you have some contracts and you have to make precise accounting what the supplier has actually provided you with and what he has left to provide. Microbiology, of course. Microbiology is very, very different from clinical diagnostic lab interface because it has a different hierarchy of materials. For example, if you have one point of in primary material and one cup and this is all, because there is no growth, it's okay. But if you have a cup and then you have a dozen cups because there was plenty to grow, it's a different tasks, and antibiotic resistance and epidemiology reports that can be very specific. It's quite a different area with its demands. It's more reasonable to consider it as a different sub-project in LIS implementation. It may be a little bit difficult, but it's worth the effort usually. Histology. Pathomorphology is a very interesting sphere, I must say, because it also has very many difficulties with materials logistics. Long story short, you may have, for example, one piece of primary material, some human organ. Then you have some amount of blocks with paraffin that go to microtomy. The amount of blocks can be very, very different, from 1, for example, to 12, to 15, to 20. Depends on the problem. And then you can have a lot of slides from microtomy, because in simple cases, histologists also you have just hematoxylineosine, and then you have the solution from pathologists. But in difficult oncology cases, when you have immunochemistry, immunohistochemistry, a lot of stains, very expensive process, you can have easily 50 slides or even 80 slides or 100 slides for the worst cases. And you have to manage with this amount of material because it's not the only case you have. You have, for example, 200 cases per day, and the worst thing you can have in pathology is to miss the samples. It's very, very bad, believe me. Not to mention different technologies, just like computer vision, just like voice recording, just like video recording of exhumation, etc., etc. And of course, the highest floor of histology automation no one actually usually cares about. It's the machine learning and clinical decision support, something like Sloan University in North America. They combine something like 20,000 pathology cases from all over the world in very, very particular problems. And they give the machine learning algorithm to analyze all these cases in order to make the machine automatically predict and automatically define, is there a lung cancer, or is there a liver cancer, or is this most definitely not. And it's a lot of funds, it's a lot of efforts, because they have already spent something like $50 million for today, and it's almost 200 millions to go with. But what is it for is quite understandable, because the qualified pathomorphologist grows very, very slowly, and it's not plenty of them. What is more important, that they may have two or three different opinions in hard cases, and the percent rate where their diagnosis for the particular cases can be very different can be up to 25%. It's not my word, it's the word of Sloan University that calculated it. So imagine the horror of the situation when you have two very seasoned professionals with two completely different opinions, and these two completely different opinions influence hardly on the rest clinical process, because it's different ways of chemotherapy, it's different ways of clinical treatment. And of course, in order to get rid of that, there is a lot of work that top pathology universities are undertaking. Not everyone can afford, but still, for your information, there are some very interesting things. And in the end, I must say that, of course, the pathologist and his microscope is the key and the core element of pathomorphology lab. But for everything in between, you can have the IT. What is IT ecosystem, integration, etc.? It's just one description from our colleagues according to Russian data exchange services. So it's regional level, it's federal level, they demand very different formats, they demand very different data. It's very good for you if you have this data exchange service or something similar to this, because you understand that if there is none, then you have to integrate it point to point. Every square on this scheme is to be integrated with another square. And it's a terrible lot of efforts to make this integration, and of course it's time-consuming to support it. So, in simple words, how usually people approach to LIS implementation, and to the implementation of any IT solution on the planet, usually, not LIS. Instrumental approach. Sir, yes sir, we can dig, we cannot dig, we can implement your analyzer or not implement your analyzer. We can implement a dozen of your analyzers for $200 each. On this place, usually our customers say, while remembering the price of their instruments, how much will cost never to get them to the instruments. Standard service. All will be done by the book. We have a PM book, we have a standard approach, we don't have a time or desire or the budget to communicate with you, to negotiate with you, to adapt anything for you. You didn't pay for this, you get what you get. Moderate maturity level, but extremely popular for high level implementations when the government says it is to be implemented by the end of the year. Here is a very small budget and no time. Come and make it. And it's very popular in Russia, and it has some unpretty aspects. And of course, partnership level. It's when you say, okay, the budget is what it is, we can find it. We need a special expert group, we need an element of consulting, we need a tailor-made solution. There is where the interesting things can begin. The project approach. So my favorite cup of the tea. Very specific results you are to achieve with the project. So the terms, milestones, budget control. Of course, someone likes Gantt chart, someone likes just milestones. I personally prefer milestones because I think Gantt chart is obsolete, and it becomes obsolete in 2 weeks after you paint it. Synchronized activities, because you name all the stakeholders involved in your project and you take them into consideration because it matters. Risk assessment, I already communicate about it. Flexibility and carefulness, also information security, etc., etc. First of all, you can combine the project briefing of what for it. There are a lot of forms. Project charter, it means. It can be only on 1 or 2 pages A4 format, and you can very, very briefly and very, very precisely compound of the desired effects, the scope of project, the team of project, and what the project is on this original initiate stage planning. In general, LIS project looks like very primitive. Pre-project analysis, then you define with the customer tasks and project scope. Below this line is the point where you already have the contract. Then you have careful project research, you have business processes, you have planning and preparation of anything you need. Technical work, hardware, integrations, analyzers, equipment, and implementation stage. Then support and development. What I must say in different, the business process. In my experience, a lot of customers usually miss the business process part. When you have to consider your process, when you have to describe it, when you have to try to imagine how it can be retranslated into the IT segment. And this work that has a lot of benefits in it. Never miss it when you take care about healthcare IT projects, and especially laboratories. And the obligations, of course. You have the responsibility matrix. I'll indicate it on this slide. Yes, it's just like responsibility matrix. You have all the project team, you have stakeholders, and you have the indicated and declarative document. Who is responsible for which aspect of your work, particularly for this project. And it's very important because when something goes wrong, someone always tells you, it wasn't my area of expertise. I didn't give these reference intervals for biochemistry, you said, but you were responsible for it. And you gave it away, so make this right. And the business process. The business process is a good idea. If you don't want the schematic approach, okay, but getting at least some text description, which can be read without tears by third parties, it's a very good idea. Schemes of laboratories is very helpful, visible. And the post-project, of course, because you have worked hard, you have done the brilliant IT project, you have installed LIS system to your lab. Now you have to live with it for the rest of your life, maybe. You have the user support, you have the system updates, you have the helps, you have the pricing for all this, you have different plans, etc., etc. And you choose the system you must be able to live with in the end. And of course, in the end, COVID-19 that has improved dramatically the speed of IT implementations, and it's improved every particular process in lab diagnostics. For instance, because the largest labs have started to work 24/7, and all the suppliers have been overloaded 3 times, and I am a member of AACC, and they have very interesting forums. One chief of clinical lab, American, was writing, and I have called the vice president of Abbott Laboratories, and I was asking him, where are my reagents? And for the first time in 30 years, he didn't know what to tell me. So this is our reality, of course, and we are already in for almost 3 years, and I'm afraid 1 or 2 years ahead of us. But, and this is the final way, who did the homework well, and who has installed a good laboratory, who has established a good business process, can pass these times much, much easier. And everything I write in here is compounded from the samples from our customers. For example, in a day and night you have a new infection division in laboratories. Okay, you have software, you have a control of it. Yes, of course, you have to solve overtime problems, you have to find personnel, but you are able to control it. Or another 1,000 samples per day for the PCR solution on COVID. Be my guest. Because if you have badly performed, badly managed laboratory, it's completely impossible to perform this task without breaking it down. New personnel, standards, needs, new government relations, new government demands, new reports that they demand usually day and night. I think it's a pretty common problem for each government healthcare system with COVID times in the world. Yes, okay, it's hard, but we can manage it. Another 10 instruments, it's very funny when you have completely new divisions of PCR or immune ferment analysis that are for COVID-19. And the customer usually calls you and says, we need another 2,000 instruments installed. Okay, we say, okay, and when? Yesterday! And okay, but it's possible. Because without a proper IT system, you have a dozen instruments, you don't have a dozen instruments. Nothing matters, nothing happens in your life. Nothing changes. Dramatic volume increase. It's terrible, usually. It's very, very hard to solve, but with a good lab, you'll be the last man standing. And the data transfer, of course. I have seen with my own eyes the regions that compound their data report about COVID situation in Excel with thousands of rows. It's just amazing because it's the only thing you have to hope for is to pray that in the night when you compound it, nothing will break down in the table. But if you are prepared for that, if you have IT infrastructure, if you have business process, if you answered yourself for every question we discussed today, then you might have a chance to be well in these times. I wish you well, guys. Thank you for your attention. If you have some questions, there is my contact email. You can write it. We can discuss it. So.
No question. Okay. Thank you.
Thank you
very much, Doctor.
Dear students, I want to add a little bit. At first, if you have some interest for